If I told you the average salary in a room was 100k dollars, would you believe it? What if I told you Elon Musk was in the room? Descriptive statistics help us summarize messy data into single useful numbers. Today we are going to calculate the mean, median, mode and standard deviation for a specific dataset. And more importantly, learn when to use each one. This first is we got a question to solve, right? So let's start with the math. We have this data set 12, 15, 12, 18, 20, 15 and 30. We first sort it. So the mean is the mathematical average. Sum them up. It will be 122 and divide by count 7. We get 17.43. The median is the middle value since we have 7 numbers. The fourth number is the exact middle, that is 15. The mode is the most frequent number. Here is 12 and 15 both appear twice. So this data set is bimodal, right? So this was all the things which we need to find it out, right? Now, the outlier effect. Notice something. The mean was 17.43. It is higher than the median 15. Why? Because of the number 30. The 30 is an outlier. It's much bigger than the rest. It drags the mean up, but the median ignores it. Standard deviation is 6.27. This tells us that on average, the data points are about 6 units away from the center. It measures the spread, right? So when to use what, right? Basically, so which one should you use, right? So use the mean when the data is symmetrically and boring. No outliers. Use the median when you have skewed data, right? Real estate prices or salaries, just like Elon Musk. One mansion doesn't skew the median price of a neighborhood, right? But it ruins the mean. Use the mode for categories. You can't calculate the average favorite color, but you can find the modal one, right? Next is an interactive visualization, right? So let's visualize this. If I click on the toggle mean, here is the mean is 17.43, right? So see how it's floating higher than the most of the data points. That's the outlier at the end of the graph, which is pulling it up. But similarly, if I toggle to the median, now here is the median line at 15. It cuts right through the dense cluster of data. It represents the typical value much better in this case. So in conclusion, we can remember the mean is sensitive, the median is robust. Use the right tool for the job. So this was all about the video. Thank you.